Hi, this is David with the Maxonics Tech Support, and today we're going to learn about digital multimeters, some of the features and functions, how to use them, and how to set them up. To start our introduction to digital multimeters, we're first going to discuss the two main types of digital multimeter. We have our auto-ranging digital multimeter that will auto-adjust to its settings, and our manual ranging multimeter that will not automatically adjust itself. You will have to turn your dial to the settings that you need. For our manual ranging multimeters, if you are testing for DC voltage or DCV, you will have options of 200 millivolts, 2000 millivolts, 20 volts, 200 volts, or 250 volts on this multimeter. If we are testing for AC voltage, you would have 250 volts or up to 250 volts AC and 200 volts AC. The next pertinent section of our manual ranging multimeter is ohms or resistance. In your resistance settings, you have 200 ohms, 2000 ohms, 20K ohms, 200K ohms, and 2000K ohms. The last handy section of our digital multimeter is the continuity test section. This is going to be very easy to test a circuit. On our auto-ranging multimeters, we're going to have fewer options. They're going to be AC voltage, DC voltage, DC millivoltage, resistance or ohms, continuity, and our amperage settings, which we're not going to use very often. Back onto our manual ranging multimeter, we're going to figure out where to place our test leads in our 3 receptacles. Under each one, you can see a description of what it's meant to do. This would be our 5 amp max for doing amperage. This is voltage, resistance, and milliamps, and COM is for our negative or our common test lead, which is generally the black test lead. Back here onto our auto-ranging multimeter, we're also going to go over where to place our test leads. We can see the red indicated test lead area has voltage, resistance, and continuity, and COM, which is labeled black, is generally where our black test lead is going. We can also do a 10 amp test or a up to 400 milliamp test for amperage testing. So we're going to test for 12 volts on our battery. We have a simulated battery with 12 volt constant, 12 volt accessory, and a ground stud on our bus bar. We're going to connect our test leads to the corresponding receptacles on our manual ranging multimeter. We're going to set our multimeter for 20 volts DC. To perform our test, we're going to touch our common black test lead to the ground and our red test lead to our constant 12 volt power. As you can see, we're getting a reading of 12.23 volts DC. Now what would happen if we did this reversed and we touched our red lead to our ground and our black lead to our power? It is just going to read the voltage in a negative form. Now we're going to perform the same test with our auto-ranging multimeter. We're going to set for DC voltage. We're going to take our test leads that are connected to the corresponding receptacles for COM and for voltage. We're going to touch our COM test lead to the ground and our red test lead to the power. And as you can see, we're reading a voltage of 12.29 on our auto-ranging multimeter. Generally, a higher dollar auto-ranging multimeter will be more accurate than a manual ranging multimeter. Now, if we were to reverse our test leads on our auto-ranging multimeter, what would happen? The same thing. The multimeter will just read our voltage in a negative form. Next, I'm going to show you how to test continuity, or what the continuity test will do for you. We're going to set our multimeter to continuity. And as a quick test, what you're going to want to do is touch your leads together. You'll get an audible sound letting you know that there is a circuit being completed. So, if you were to touch between the negative battery terminal and the positive battery terminal, this is also going to beep, letting you know that the circuit between positive and negative is completed. If a circuit was not complete when we are testing for continuity, the multimeter does not indicate that there is a connection between our switched and our ground. If I were to turn the switch on, the circuit becomes completed, and turn the switch off, and it goes away. To continue with our continuity testing, we brought in a nice speaker. The speaker's voice coil is wrapped around to where the positive and the negative create a circuit. So you can use your continuity setting to test the voice coil. On this multimeter, it also gives you an approximate resistance displayed on the screen. This is not the most accurate resistance possible. So for a more accurate resistance measurement, we will change our multimeter to resistance. We're going to insert our test leads into our speaker's voice coil terminals. This speaker is giving us a resistance of 3.1 ohms. We're going to go ahead and check the other side. And the other coil is showing about 3.4 ohms. Now, something kind of interesting with the speaker, as it moves, the resistance will change. But at stable, it will always come back to a resting resistance. To demonstrate, on our manual ranging, we're going to set for resistance. We're going to set for 200 ohms. Then we'll do the same thing, inserting our positive lead and our negative lead. And on this multimeter, our resistance is reading 3.5 ohms on the same coil that was just reading 3.4. So slightly off, but not bad at all. We'll do our other. And this coil is reading about 3.3 ohms. And also, if we apply pressure to the speaker, it will change that resistance, but it will come back to the same 3.2, 3.3 ohms originally tested. That's going to conclude our training on a digital multimeter. Thank you for coming and joining us on this adventure. If you'd like to see more videos like this, please subscribe to our channel. I'm going to be doing many more videos on fun things like how to set an amplifier, how to test an amplifier, and how to test your speakers. Have a great day.